Hey everyone, how's it going? Since we can't do this in person, Mark decided to stop by, so we're doing this together. Can everyone see our screen? Awesome, you see us.
See you. Hello.
You can see us. Can you see our beautiful BSidesNoVA present PowerPoint? Hey Jay.
Can everybody see the presentation, Hacking the Cloud?
Are we sharing? Am I sharing? Share screen? Okay. Okay, good. Thanks. Just making sure. Hello, everyone, and welcome to Hacking the Cloud, XXE, and the AWS Metadata Service, although we'll talk about some other metadata services today. I'm Clint Kehr, here with Mark Schmidt, and let's get rolling here. So if you read the description of this presentation, why are we doing this? Well, XXE is a vulnerability that is important to us as hackers. When we think about hacking something, we should also be thinking about the environment we're in. So why this talk came about is because we've actually seen this in real life. And you could stop at XXE, but once it hits the cloud, you hit a metadata service, and we're going to show you all the interesting things you can do with this metadata service. So just an overview of the talk, we'll explain who we are. We'll start from the ground up talking about XML. We'll talk about XXE. We'll talk about what the metadata service is and is not. And then we'll talk about how XXE and metadata service intersect. And then we're going to talk about AWS Instance Metadata Service version 2 and how that's kind of a safeguard against XXE attacks. We'll talk about how you fix it, although we're hackers, so probably, we'll give our best guess. And then we'll open up to questions. Because we didn't pray to the demo gods today, the demos are recorded, and we apologize for the volume. I have it all the way up. I apologize if the videos are not clear. We try to do them 1080.
It should be okay.
It should be okay. We'll see how it goes. We'll roll the dice. So with that, I'll let Mark introduce himself.
So I'm currently working on a responsible disclosure program for a financial company. I'm a former blue teamer. I was in the SOC for about 4.5 years. Before that, I actually was a lead armored vehicle technician for diplomatic security for about 13.5 years, traveling the world, fixing armored cars and running a team. So complete career change for me.
Oh, passing it back. All right. Clint Kehr, I am a former special agent with the Department of Justice. So like Mark, I didn't start out in cybersecurity. I kind of fell into a group in DOJ that dealt with the dark web and kind of immersed myself doing operations on the dark web, which I can't really talk about. If you buy me some beer later, maybe I can tell you some things. We'll see. Anyway, former Navy Reserve officer. I'm also a member of VetSec, which I know is part of this conference. So if you're a veteran and want to join, check out VetSec. I've worked on cyber threat intelligence teams, and I worked with Mark on a responsible disclosure team. I'm currently a manager on a pen test team, and I make and break home labs. It's kind of a hobby of mine in my free time. And I have a bunch of certifications, as you can see, offensive, defensive, etc. So with that, here's a disclaimer. I'm at best a mediocre hacker. I'm not a developer. I won't speak for Mark, but I'm kind of a mediocre hacker. So if you have some very interesting questions about development and AWS infrastructure, as you can see out of all my certifications, I don't have any AWS certifications, but we are not developers. So if you want to get into the weeds there, we can't help you with that.
So we're going to start off by talking a little bit about XML and what it does. So XML stands for Extensible Markup Language. It's designed primarily for the transportation and storage of data, not necessarily the presentation of data, like its markup counterpart HTML that everybody knows. The formatting of XML uses a tree-like structure of tags, elements, and attributes, all in a nested format. It does not use predefined tags like HTML. If you're familiar with HTML, you have predefined tags like H1 through 6 for header, title, body, things of that nature. With XML, it's completely, you can name of your choice. You can label your tags however you like. Like HTML though, it is not considered a programming language. It's considered a markup language. And with markup languages, they're human readable, and they're more for defining content and structure of a document. So we're going to get into the syntax of XML. So XML is case sensitive. So for example, here in the bottom picture, with my opening tag root, it's all lowercase. I nest in all my elements and sub elements. When I go to close that tag out with the same root tag, if I were to accidentally put a capital R, it would actually break the parsing of that document. You'd probably receive an XML parsing error like mismatched tags or something like that. Elements must have XML must have a root element. So every properly formatted XML document must have one root element. There are cases where you can define multiple root elements, but that's in the case of using a DTD, which we'll get into in a little bit. So elements must also have opening and closing tags. I kind of mentioned that already, but so when I create my root tag, my opening root tag, I nest in a child tag. Every element that I put in there, I must have a closing tag. Otherwise, again, it will break the parsing, and you will receive a parsing error, probably missing closing tag or something similar. So XML, the top line there is the XML declaration. So I say this is mostly optional just because if you are using UTF-8 encoding or UTF-16 encoding, you do not need this line. It's not required. If you are using any other encoding other than UTF-8 or UTF-16, this is a required declaration. So what is a document type definition or a DTD? So this is something that defines the legal structure and the legal entity or elements allowed within a XML document. This can be passed both inline within your XML doc or out of band or through a DTD file. So I'm going to go through just some of the pieces of a DTD. This isn't necessarily part of the DTD, but again, this is where you have to declare your encoding and version. Again, if you're not using UTF-8 or UTF-16 encoding, you must have this line in there. This is where you would define your entities. So think of entities as sort of an alias name. You see here I have name 1 and name 2, John and Tom, and that's what you would use to, think of it like a find and replace within your code. So here, it's not part of the DTD. I just wanted to sort of show an example of how you would use an entity within XML. So you'll see here I have my customer element and then my sub-element name. Then I use my entity there, which would ultimately replace, name 2 would ultimately replace with Tom, name 1 with John. So what is XXE injection? So XXE stands for XML external entities. Which sort of like the entities you saw in the DTD there. So it is a web vulnerability where attackers can basically fool or manipulate an XML parser to do things it wasn't really supposed to do and retrieve data from the system. So some of the things you can accomplish with XXE is viewing system files on an application server or file system, interacting with a backend system or external system that the application has access to, and then also leveraging SSRF to compromise additional internal services. You can also use it to leverage SSRF to reach out to an your attacker domain, where you might host a malicious DTD file. So we're going to cover 2 types of XXE injections, in-band and out-of-band. There are additional ones, but these are the main 2 that we are going to cover. So think of this, when you think of this attack, think of it sort of like how you would go to your browser and type in file, Etsy password, or you can do it on your Android device as well through a browser. You could go to SD card 1 and then pull back your system files there. Here we are with in-band, we are actually delivering our DTD through the actual code itself within the XML. So You'll see here I specify the doc type hack entity, the planet, and an entity, the planet is basically an alias for a system call to the Etsy password file. And you'll see below when we're actually calling for the product ID, we are actually sending it the planet, which is the system call for the Etsy password file. So out of band, like I mentioned before, out of band is when you are calling an external DTD file. Why would you need to do this? So in this case right here, this is an example of sort of the same thing I did before. I attempted it in band, passing it the system command for file Etsy password, but I received invalid product ID and no data returned. So with the out of band, you are actually able to contact an external DTD to try to deliver the data to a listener you have set up, which is exactly what I'm about to show you in this demo that we're going to set up. So hopefully you guys can hear this. The volume sounds low on our laptop, but everybody said it sounded fine when we did it in practice.
So in this demo, we'll be showing you blind or out-of-band XXE injection through the use of SSRF to pull down system files. For this demo, we're going to be attacking our well-known Seasides 2021 login page that happens to have an XXE vulnerability. We're going to have to do a couple things first. We're going to have to spin up an Apache web server. We're going to have to run an ifconfig just to figure out the IP of the attacking machine. And then we're going to go ahead and curl the IP just to make sure that our web server is up and running. So let's go ahead and start the Apache web server. All right, now that we have that started, I'm going to go ahead and run that config 237. Now let's go ahead and curl that IP. Looks like we're hitting a page, which is great. It means our web server is up and running. So now we can move on, and we're going to go ahead and modify our payload. So a couple things here within this DTD file that we'll be calling. You see some parameterized entities. Basically what we're doing is we're forcing the XML parser to grab the contents of the Etsy passwords file and assign them to the P1 entity. The same with the traffic back to our system. We're going to give it our attacking IP and port of our choice. And what it's going to do is, and then also a non-existent file path. And what it's going to do is append the Etsy password file through the P1 entity on the end of it. That's nested within the P2 entity, but it's labeled as E1. And you'll notice E1 once we start capturing traffic. It'll make a little more sense. So let's go ahead and modify this. And port of our choice. Go ahead and save this file off. Make sure everything's right. Save this file off. And what we're going to do is go ahead over here and we're going to run the curl one more time, but we'll throw the file name on the end of it just to make sure that we can reach our file. Looks like we can see the content, which is great. I'm going to go ahead and cat the server logs just to make sure that we're getting traffic. As you can see here, you can see the get to the file name, which is great. So everything's working as planned. We can move on to intercepting. I'm going to move over and turn intercept on within Burp Suite, and we're going to go ahead and attempt to log into the application. Pretty much put any password you want. Hit login, and now you can see we captured the traffic in our intercept proxy. I'm going to go ahead and grab this, send it over to Repeater. And after that, I don't really need this web page anymore, so I'm going to expand this and move over to Repeater, where we can see our post request. So here you can see the post request with the username and password. We don't need any of this. We're going to go ahead and input our own XML. And our IP address for our attacking machine with our file name. Oops. Here is where we're going to enter that E1 entity. Ampersand E1 with semicolon, never forget the semicolons. So essentially what's happening here is we are using this to call back to our DTD file, and then that E1 entity that you saw within our payload is being used to call that, to use that attack traffic to send it back to our listener that we're going to set up. Oh, whoops. Sorry, I forgot. We need to change this to XML so it knows how to read it. So we're going to go ahead, we're ready to send it. So we're going to go ahead and set up a netcat listener on our specified port. So now that we have that set up, we should be ready to go. As soon as I hit go, you should see the traffic come back with the Etsy password file appended. And there you have it.
Oh, there we go. We're back. We're back. All right, so Mark did the hard stuff. He did the out-of-band XXE attack, which looks really cool, but requires a whole lot of infrastructure setup. So now if we're hackers or pen testers or attackers, what we need to be thinking about is what our environment is and how we can leverage this vulnerability if it's in the cloud. So if we're talking specifically about AWS and EC2 instances, or their VMs, if you will, they have this metadata service, which is a REST API running on 169.254, 169.254. And if you call this instance metadata service, say that five times fast, I've tried, it doesn't work out very well. You can pull information like the instance name, the AMI, storage information, configuration information, which is all well and good. But as attackers, we should be thinking about keys and tokens. Because in AWS, if we can access keys and tokens and throw that in the AWS CLI command line interface, we can try to hit other services, maybe other EC2 instances, maybe S3, maybe Lambda, maybe mess with the account itself. So essentially break out of the EC2 instance, which is why this makes this vulnerability much worse when it's in the cloud. Now, it's not just AWS. GCP and Azure, I always say it wrong, also have instance metadata services in them as well. So you'll see that GCP has this metadata Google internal metadata service, and you have to add a header to that, which is to mitigate SSRF attacks. You have to add metadata flavor Google. At one point, you could hit, instead of V1, you could hit V1 beta 1 without using that header, and people got paid lots of money in bug bounty programs for that. But unfortunately now it doesn't work anymore. So that's sad for us. Now on the Microsoft side, they too use 169.254, 169.254, and you have to add a header for this of metadata true. I will note that if you encounter issues with WAFs, you can always, which we'll look for or block 169.254, 169.254 You can always maybe register your own domain with that IP address. I'm just going to throw that out there. And how does this work, or does this happen in real life? That this talk is based off something that Mark and I saw in real life. But as you see here, it's something that does happen. And this is kind of a potpourri, if you will, of different vulnerabilities that have been found. And as you can see, a critical vulnerability that was found leveraging XXE with SSRF, hitting a metadata service. These top two are on HackerOne. The other one was a medium, but he still got paid $10,000, which is pretty nice. And then you can see in GCP itself, they've had issues with their own metadata service. So this affects many large companies and is something to be aware of. All right, so we talked about meshing these two services, or this attack, the XXE attack, with hitting the metadata service itself. And we can see here that we're enumerating keys, which is for ultimate pwnage, which is what we'll see later in the demos. And speaking of demos, I think we have one coming up, and we do.
All right, so we're doing our pen test, and we've come across this login screen. So what I can do is just try entering test data, test, and test. And we can send that forward, and it says you have logged in as user test. Now, if we look at this using Burp Suite, we can see what happened is we made a post request here. Send this to repeater. We made a post request to this XML injection PHP endpoint, and it has you have logged in as user test. Now we want to test this to see, test, if we can inject our entity into this. So the thing about XXE vulnerabilities is naming isn't important here if the vulnerability is going to be here. So I can actually change this. And what I'm going to do here is, and you don't need encoding UTF-8 as well. So what I'll do here is entity test, and you can see I have test down here. And what should happen is this should say you're logged in as XXE. So if I send this, we see that we're able to inject this entity here of XXE. Now, of course, we can look for files like Etsy password, which you've already seen, but I want to do something a little bit more interesting. I want to see what the MAC address is of this instance. And how I can do that is, as you can see, I'm back to having root here. Of course, you don't need that. Is procnet arp. And I see that I have an IP address and I also have my MAC address. Now, if I research this, I see I'm in a Docker, which is a pen tester. If we're in a Docker, it introduces some possible issues there because we're not actually on the host. We are in this Docker, and we're going to try to break out of this Docker. So we're stuck in a Docker. The other thing I can do is I can try to enumerate PHP. Now, PHP is a server-side language, so I can't read it by default. You know, if I look at the XML injection endpoint, and I view the source of the page, I just see you have logged in as user, which doesn't really tell us what is inside the PHP. So what I can do is I can use a filter here. So you might have seen this in local file inclusion vulnerabilities and things like that, but I have this PHP filter convert base64 encode, and now I'm trying to look at this resource, this XML injection PHP page. So if I send this, I can see I have a long string, and if we know anything about base64 encoding, this looks like possibly base64 encoding. So what I can do is take this and throw it in decoder, decode as base64, and you can see that now I see the PHP of the page. I can see it's looking for user and password credentials, and here it echoes back, you have logged in as user, whatever this user is entered as. And I have some clues possibly as to why this is vulnerable to XXE, which we'll talk about later. Now, if we go back, we figured out XXE is possible, but let's figure out further what our environment is. So I'm on cyberninja.com. Well, what is cyberninja.com? So let's go to our trusty Terminator terminal here. I'm going to do host cyberninja. And I can see I have an IP address of 2323491, and I can run a whois of 2323491. And we can see that we're dealing with an Amazon EC2 in the region that we're in. So now we should start thinking about the metadata service if we can reach this endpoint. So what I'm going to do is I'm going to go back to Burp Suite, and we're going to try to see if we can hit the metadata service. So all that requires us to do is know the IP address, which is the same in every EC2 instance. That's 169.254.169.254. And you can see I've hit the metadata endpoint here. So you might see a whole bunch of things here. We're looking for latest. AWS in their documentation says they have all of this information because of previous versions of the metadata service. And if you're running a script from a particular point in time, you can still use these versions of the metadata service. But I'm going to use latest. And as you can see here, I have metadata, well, I have dynamic, metadata, and user data. Dynamic, if I go here, this gives me a whole lot of juicy information about this EC2 instance. If I go to document, here's all this great information here about this EC2. You can see account ID, architecture, availability zone, all this really, really good information that might be useful to us later. We can also see other things like our SSH public key. Well, you know, the private key would be a whole lot better if we had the key pair. But in the EC2 instance, you can see latest, instead of dynamic, now I'm at metadata, which is the metadata service. Public key 0, open SSH key. Space, it might not like that. And here we see this public SSH key. There's some other things we can see too. We can see the internal host name. Right here, which gives us the internal IP address, your private IP address. Now you're probably going, Clint, okay, this is all good and great, but what about getting the secret key, which is really what we want to use to further attack this box. So to do that, what you want to do is when we're in metadata here, you want to look for IAM. If you don't have IAM, you can still enumerate keys for the EC2 instance itself. The issue though is, and we'll talk about this later, is that you can get this, you know, you can use this in the AWS CLI, but the problem is it doesn't really do anything. So you're kind of at a dead end because it's just the EC2 instance itself. Now, if you have IAM here, you can go to security credentials. And now we see there, it's called service role. It may be different for you when you're doing this. And now I have the access key ID, the secret access key, and the token. And I can use this in the AWS CLI to do further enumeration and also exploitation as well, which is the fun stuff. So we'll talk about that a little bit later. All right, so we're doing our pen test and we've...
Okay, all right. Now you can see me again. So I talked about this in the demo. If you don't see an IAM role attached to the EC2 instance, what can you do? Well, our friend Rhino Raider, who is a much better hacker than I am, and Space Raccoon did some research on this. I recommend that you go to his blog here and read what he was able to do. At some point in time, he was able to cause a denial of service against the EC2 instance, but had issues with that. And ultimately, his conclusion at the end is more research is needed, but there's really not much you can do solely with the EC2 credentials themselves. As you can see here, I'm running AWS STS get caller identity, which is like a who am I. I was able to do that and something with DynamoDB, but that was really all I could do with this EC2 instance when I was trying to, when I imported these keys and tried to hack it. Now, once you get keys to the IAM role and you want to figure out what permissions you have or what rights you have, doing it manually is going to be very, very, very difficult. So I don't recommend that. So there's tools like this, Pacu, however you want to say it. The latest version of Kali Linux that just came out, I think last week, has this in it, which is great and just shows that AWS is a service that's being looked at more by hackers. And there's also this GitHub page here for enumerate IAM. I've used this Python script before. It makes a whole bunch of API calls and kind of hangs. I've never had it get through everything before. So it's good as an initial pointer of what permissions you have. But again, I've never really had it successfully carry out a full enumeration. And thanks, Chris, for putting that, that domain in there. So now it's time for another demo. Now that we've done some enumeration through the AWS metadata service, we're going to really rely on luck from this point out. We're going to hope that these keys or this role allows us to read S3 buckets. And we're also going to hope that we can connect to the instance itself. And one of the ways we can connect to the instance is through this AWS EC2 Instance Connect send SSH public key command, which is going to push a public key on our hacker or Kali box onto this instance. So you can see here that I have an instance ID, which I can pull from the metadata right here, from this endpoint here. I can see also that we see a user Ubuntu, and we're hoping that that's correct because we know that the box itself is running Ubuntu. And that's a username. And we're also hoping the availability zone, which there are a number of on the east, is US East 1 Echo. Now, if you mess up or if you don't get it right, it will be verbose and tell you that that isn't right. So it's a little bit of guesswork some of the time. And here we're setting our SSH public key, which is in our root directory, our SSH, our hacker public key. So if we issue this command, we see that success is true, which is great. And now we're going to try to connect via SSH to the box. Obviously, depending on security groups, you may not be able to do that, but in this case, we'll keep our fingers crossed. We're specifying our hacker private key file on our local machine and the Ubuntu user at that IP address. So as you can see, we've been successful. We're able to SSH into the box itself. And now let's see what we can do. So I always like to do sudo L to see what permissions I have. You can see the user Ubuntu basically has full access to the box. So let's sudo su. So now we're going to be root. And let's see if there's a flag. Well done. So we can see that we've successfully grabbed the flag. I know that's a little capture the flag-ish, but that's the importance of knowing how to escalate privileges on a box like this, or how to figure that out. So now we've successfully rooted the box. Spoiler alert, we do get caught in the end, but ultimately we've achieved our objective of leveraging the XXE vulnerability into enumerating the AWS metadata service, and ultimately getting onto the box itself, and not on the Docker, onto the box itself, and getting the flag. Now that we've done some, I'm repeating myself. All right, so I want to talk about security groups briefly. So if you actually try to go to cyberninja717.com on port 4444, hopefully you can't get on that. And when I made these VMs, that's an important thing as well. And something to talk about is in security groups, you can specify IP addresses or a range of IP addresses that can reach that particular port, and it's EC2 specific. So if you can hit cyberninja717.com on port 4444, let me know, because I'll need to change that. But what's guard duty? So guard duty for AWS will alert you if it thinks something malicious is going on. So in the case of me trying to hack or use these AWS credentials, is one, it saw that I was using it from Kali Linux. And the other thing it saw was that I was using the credentials outside of, and you can see my IP address there, outside of that EC2 instance. So as attackers, what we should be thinking about is one, maybe not using Kali Linux when we get this metadata service or we get these keys. So not using Kali Linux, and perhaps using an EC2 instance, because maybe AWS doesn't know if you're using an EC2 instance, it will not fire this alert off in guard duty. All right, so we saw how easy it was to hack IMSDV1. Now we get to IMSDV2. So we're upping our game here. This is a little bit, well, it is a protection against server-side request forgery attacks or XXE attacks, because it enters a put request, or you need to use a put request now. So what's going to happen is, because it's SSRF, you can't do a put request. So you'll see here, if you are using Instance Metadata Service version 1, oh, thanks, Josh. You can generate a token for up to 6 hours, and your subsequent calls, you need to use that token to call the metadata service. All right, so again, I don't have a certification in AWS yet, as Jamie mentioned, but Instance Metadata Service version 1 and version 2 are both available in EC2 by default. And good news for us hackers is there's no plan to disable Instance Metadata Service version 1, so we can keep using SSRF. But what you can do is enforce version 2 on all your EC2 instances going forward. And that's what I did for this next setup, is I disabled Instance Metadata Service version 1 and only allowed using Instance Metadata Service version 2. So now another demo.
So we're testing another web application here, BSidesNoVA 2021 registration form. We can see we have Burp Suite up. I'm going to turn Intercept on, and we'll fill in our name, our phone number, and our email, and our password. And you can see here it sends a post request to this process.php endpoint with all of our information here. What I'm going to do, because I have Burp Pro, is I'm going to do an active scan on this. So I'll open this up and let's see our issue activity. As you can see here, I have XML entity expansion. So I don't think we talked about this before, but with XXE, you're able to do this entity expansion, which causes basically a DDoS attack. So that's another thing that you can do using XXE. Of course, DDoS is something we want to clear with people before we try this. I've not tried it before, so but this is just demonstrating that it could cause a denial of service attack. Also, you can see our XXE attack here. We have our request for Etsy password, our response, and also another request here. As you can see, this is our SSRF here, reaching out to this Burp collaborator client. And you can see there's DNS interaction with the collaborator client, as well as HTTP interaction with the collaborator client. Now, what Burp doesn't check for in this active scan are, one, whether it can hit the metadata service endpoint. And the other thing is if expect is enabled with PHP. So we can see that we get Etsy password, but let's see if we can also do remote code execution with expect. Now, don't expect to be there by default in PHP. It's not. It's something I had to install separately. But you can see here I can do ID. I'm going to erase this so it looks a little cleaner. And you can see that we are data. Now, of course, it all depends on the permissions of data, but I'm going to hope that I can hit the web root and upload a web shell. Now, just to see if we can access the instance metadata service, let's give that a try. 169.254, 169.254, and we can see that nothing comes back. So I know from my enumeration before I made the video that this is an EC2 instance, of course, because I made it. So something's up here. Either metadata service is disabled or they're using instance metadata service version 2. Now, because instance metadata service version 2 uses a put request, it's a way to mitigate this SSRF type attack. Because I can't do put. I can try put with expect. I can tell you the interesting thing with expect is it is incredibly difficult to make things work because you need to have an interesting naming convention or syntax when you use it. So normally if I'm on a box, I do uname a Linux box that is. As you can see, this doesn't work. What I have to do with expect is $ifs as a space and play around with single quotes and see if uname a works, which now it does. So in order, I tried this with the metadata service version 2. I'm able to get a token, but I'm not able to follow up hitting the metadata service, probably because some characters are sanitized with expect. So what I'm going to do now is I'm going to curl, because I've compromised that Cyber Ninja site, what I'm going to do now is curl a web shell that I have onto this box and hope that it works. So you can see here, again, the naming, the syntax is interesting, curl ifs, O, so we're just big O, so we're just downloading the this file, and it's going to download this webshell.txt. Need to add a single quote. And I should have uploaded it. It looks like it was successful. If I want to verify that, I can go back here and do ls. And I do say I have webshell.txt. So what I have to do is I have to move that and make it a PHP file. So again, ifs with the $. We're going to move webshell.txt. Again, we know the $ifs to webshell.php. Send that. It says no such file or directory. Let's take a look at that. You can see it's webshell.php. So let's go to let's hope that this works now. As you can see, hacker@hacks.net was already registered, unfortunately. But we'll do webshell.php. And let's see if we can get RCE, and we see we can. So now here is where I'm going to check where I can do that put request with the metadata service. So what I need to do first is I need to generate a token and see if instance metadata service version 2 is enabled. So I'm going to set it for 21,600 seconds, and I get my token here. All right, so now that I have my token, I am going to do a curl request using that token to the IAM role, hoping that this box has one, and try to download info so I can put it into the AWS CLI. You can use tools like PackU and IAM Enum to see what permissions we have, but let's not get too far ahead of ourselves. So we see we have this IAM role of S3, may be different for you. So again, we're going to curl and I'm going to go all the way to the end, do S3, execute that. And you can see that we have the access key ID, the secret access key, and the token. So in my cool Terminator shell, I need to export this information. So I'm going to export my access key ID. Here we go. I'm going to export my secret access key. Gotta love the Z shell that remembers everything. Unfortunately, it's not the same information we have here. And our token, which of course this means that these are temporary credentials. All right, so it actually gives you an expiration with Zulu time here. I'm going to copy this. Now again, once I have this, I can do some enumeration with the enum Python script, IAM enum, or I can use PackU. I'm just going to try to see if I can enumerate S3 buckets. So you can see here that I can see a bunch of S3 buckets. Of course, the most interesting one here being BSidesNoVA. So if I want to do this again, S3, let's see what's inside this bucket. We see we have one file, secret info. So let's grab that. So I'm going to copy that to my local directory here. You can see it was downloaded, and I can cat this, and we can see super secret info. Just to show you that this isn't accessible to anybody on the internet, I'm going to paste this in here. As you can see, BSidesNoVA, that's our S3 bucket, secret info, and you can see I have access denied. So that's to show I can pivot from this XXE vulnerability that has Instance Metadata Service version 2 installed in it, and I can get onto the AWS CLI and access other services, in this case S3. In the other demo we saw we could upload an SSH key. But that's all to show that, that we can do a whole lot more with an XXE attack.
All right, so a couple things I wanted to mention because I did that. That was a 9-minute demo I had to record, and I made some mistakes. One, I wanted to thank AWS for having an example of XML with that access denied page. The other thing is, it's not a DDoS attack, of course. It's just a denial of service attack. We're not using a botnet army. And if you notice at the end, I catted secret info, or I catted secret file, and I downloaded secret info. I guess I just downloaded so many secret files, I couldn't keep track, but I can assure you that it basically says the same thing. And also the fact that the role name gave us clues, right? So the S3, of course, you could probably guess, allowed us to enumerate S3. So David had a question: is the value for the session token specified by the attacker? No, I believe you can specify that in your instances panel. I think the default the default length that a token can last is 12 hours. From what I read, I think 12 hours, but you can set it from the CLI or in the console. Yeah, so can you downgrade to version 1? So that's a good point. If you have access to the AWS CLI within the EC2 instance, can you issue a command to downgrade to version 1? I can tell you for that EC2 instance, I didn't have AWS installed. Of course, you could install it, right? Living off the land. So that's a possibility, right? If we have sudo permissions and we can snap install the AWS CLI, maybe you can configure it from within the EC2 instance. That's possible. I've not tried it, but definitely something worth exploring is a downgrade attack. So, Mark, back to you.
We'll just wrap this up. So how do you fix this within PHP? You can see here, disable entity loader. It's set as false, mark it as true. You would disable the entity loader within PHP, and that would basically mitigate this vulnerability for XXE. With any other code, it's not working. With other languages, so as of version 2. Or libxml2 version 2.9 for C and C++, I believe XXE is disabled by default according to gnome.org. But like other languages like Java, as far as I know, that they are still enabled by default. So you would have to manually go in and disable external entities, which is the main way to mitigate this vulnerability. But we thank you guys for joining our presentation. If you have any questions, feel free to put it in the chat.
Oh, Steve, another thing I want to say is it was because the server was running as www data, the Docker was running as root, which, you're in a Docker, which makes it, you can issue any command, but you're stuck in a Docker. And the other one, it was www data, and I actually had to chmod the web root directory to allow file upload because it wasn't there, but you couldn't do it by default. So I kind of cheated, if you will, to allow uploads to that directory. I mean, you could chain it together because you could go to the temp directory and upload something there and hope that you have LFI. But that's just another possibility there. Any other questions before pizza and beer? You guys have all been eating, hopefully.
We're just two dudes sitting here.
Just
we
two
got
dudes.
5 minutes.
I know.
Thank you, guys.
Appreciate it.
Thank you for all the good compliments.
All right. Well, have a good rest of your lunch, and we will talk to you later.